Good morning and welcome to the first of 2 days in talking about absolute value equations. Tomorrow we'll look at inequalities, but I wanted to split this up to make sure that we have time to really focus on how to solve absolute value equations and make sure we have a good understanding. So my first question for you is, what is an absolute value, or how do we find the absolute value of a number? The absolute value of a number is its distance from zero. So if I'm looking at the absolute value of -6, what this question is asking is how far away from 0 is -6? So if I put a point here and count to 0, I'd count a distance of 1, 2, 3, 4, 5, 6. It has a distance of 6. So I would say the absolute value of -6 is 6. The absolute value of +6 would mean how far away is this point from 0? It's 1, 2, 3, 4, 5, 6 away. So what I notice is that even though the number inside the absolute value bars was different 2 different times, we got the same answer. Why do you think we cannot have a negative answer for absolute value? We can't have a negative absolute value, or the value of a number of an absolute value cannot be negative because it's measuring distance. And so I wouldn't say, hey, how far is it from here to Granada? And have you say, oh, it's about -70 kilometers. That wouldn't really make sense. We would say it's about 70 kilometers. You would never measure distance in a negative. It's always measured in a positive. And so therefore the absolute value of a number is always positive. It cannot be negative. So when we're solving an equation, because we can have, if we look at the previous problem, we saw that we had 2 different numbers put inside the absolute values that gave us the same answer. Similarly, that means that I could have 2 different numbers in here that would give me 18. I could have what's inside the absolute value bars equal 18, but I could also have what's in the absolute value bars equal -18. Now keep in mind, I'm not actually making this number here negative. I'm saying I want to make this number here be 18 or -18 because that will make this a true statement. When I solve it, I'm going to subtract 9 and then divide by 3. I get x equals 3 and minus 9 again to both sides. Divide by 3. And I get x equals -9. With these problems, it is going to be a requirement that you do check your work. And you'll see why a little later on, but it's also just a good habit to get in to check our work. So if I want to check x equals 3, I can say the absolute value of 3 times 3 plus 9 equals 18. So then I would have the absolute value of 9 plus 9, absolute value of 18 equals 18. This is a true statement, so that means that x equals 3 is one of our solutions. If I substitute in -9, I get 3 times -9 plus 9 equals 18. So then I'd have -27 plus 9 equals 18. This would give me -18 equals 18. And this is true because the distance of -18 from 0 is 18. So that means that both of these are solutions. So what do you think the first thing I need to do here is? In order to solve for an absolute value, I need to get the absolute value by itself. So I'm going to subtract 7 to both sides. And then I'm going to divide both sides by 2. Now, my absolute value is isolated and it's equal to a positive. And that's good because remember, absolute value measuring distance, so it has to be positive. I'm going to drop my absolute value bars and I'm going to write this twice. 5x minus 3, I'm going to first set it equal to 7 And then the second time, I'm going to set it equal to negative 7. And again, remember, I'm just trying to make what's inside the absolute value bars equal to 7 and negative 7, because both of those, when I take the absolute value, give me 7. So I've got plus 3 to both sides, and then divide by 5, x equals 2. Over here, I'm going to add 3. 5x equals negative 4. Divide both sides by 5. And I get x equals negative 4/5. Please leave your answer as a fraction. So if I check my work, I'm going to plug it back into the original problem. And I'm going to get 10 minus 3 is 7. And then add 7 to the end. Absolute value of 7 is 7, so that would give me 2 times 7 is 14. 14 plus 7 is equal to 21. So that means that this one worked, and x equals 2 is a solution. Negative 4/5, not as difficult to plug in as you might think, and I'll show you why. So I've got, think of this as 5 over 1. My 5s are going to cancel, and I'm going to get 2 times negative 4 minus 3, which is negative 7, plus 7 equals 21. I know that the absolute value of negative 7 is positive 7, and so 2 times 7 would give me 14. 14 plus 7 is 21. That is a true statement. So that means that x equals negative 4/5 is also a solution. All right, so for this one, I'm going to start by getting the absolute value bars by itself. I'm going to cancel out my negative 2's, and I have absolute value of 7x, equals negative 7. Why do you think this is a problem? It's a problem because this is telling me that the absolute value of some number is equal to a negative number. But remember that absolute value cannot be negative. Absolute value can't be negative. So that means that the minute my absolute value bars are isolated, and this is a negative, I can write no solution. Now be very careful. If you have something that looks like this, don't just see that negative over here and say, no solution. Because if we divide both sides by negative 2, we actually end up with a positive 7. And now my absolute value bars equal a positive number. So this one we could solve. So this one we could solve, but this one we can't because our absolute value bars equal to negative. All right, let's make it complicateder. The absolute value bars are by themselves, so I'm going to go ahead and write it twice. I've got 6x plus 3, 6x plus 3. And I'm going to write this one as is the first time. And the second time, I'm technically just multiplying everything by negative 1. So really all I'm doing is changing the sign of everything on that side. But I can't just change the sign of the 4x, the negative 4x. I have to change the negative 4x and the positive 5. So make sure you get both of those. I'm going to add 3 to both sides. I'm going to add 4x. And I get 10x equals 8. Divide both sides by 10. Yes, you do have to leave your answer as a simplified fraction. X equals 4/5. All right, next I'm going to solve this one. Subtract 3. Oh, I made a mistake over here. Should have subtracted 3. That's going to change my answer. So that'll be 2. That'll be 2. And that'll be 1/5. Sorry about that. 6x equals 4x minus 8. Subtract 4x to both sides. And I get 2x equals negative 8. So divide both sides by 2, and I get x equals negative 4. All right, checking my work. This is where checking your work comes in handy. If I hadn't caught that mistake with the minus 3, I would have caught it there because something wouldn't have worked. So if I plug in 1/5, I get 6 times 1/5 plus 3 equals negative 4 times 1/5 plus 5. So I get 6/5 plus 3 equals negative 4/5 plus 5. Please just get in the habit of using fractions. Think of this as 15 over 5 because we have to have a common denominator. And this is 25 over 5. Here we would get 6 plus 15 is 21 over 5. Here we would get negative 4 plus 25 is 21 over 5. And that is a true statement. So x equals 1/5 is a true statement. X equals negative 4, I would have 6 times negative 4 plus 3 equals, and I'm going to go back to the original problem. I'm not going to plug it in here. I'm going to plug it in up here. So negative 4 times negative 4 plus 5. This would give me negative 24 plus 3 equals 16 plus 5. So I'm going to get absolute value of negative 21 is equal to 21, which is true. So x equals negative 4 is also a solution. All right, last one. If I'm given this problem, I see my absolute value bars are already alone. So I'm going to do 2x plus 3 equals 3x plus 2. And then 2x plus 3 equals negative 3x. And remember, I have to change all the signs. So negative 3x minus 2. Let's subtract 3. And then subtract 3x. These would cancel out and we would get negative x equals negative 1. Divide by negative 1. I get x equals positive 1. Over here, subtracting the 3, I get 2x equals negative 3x minus 5. Add 3x to both sides, and we get 5x equals negative 5. Divide both sides by 5, and x equals negative 1. But I need to check my work. Some of you are rolling your eyes at this point. But we're going to have the absolute value of 2 times 1 plus 3 equals 3 times 1 plus 2. So we're going to get 2 plus 3 is 5. 3 plus 2 is 5. So that means that this one worked. Yep, true statement. Let's plug this one in. Absolute value of 2 times negative 1 plus 3 equals 3 times negative 1 plus 2. So I'm going to have negative 2 plus 3 equals negative 3 plus 2. This would give me the absolute value of 1 equals negative 1. This is not true because the absolute value of any number has to be positive. So this is not true. And when this happens, when we solve for x and we get an answer that when we plug it in is not true, this is called an extraneous solution. And in your homework, you'll see it'll say solve for x or solve for the variable, check for extraneous solutions. So that means that this one is not actually a solution and only x equals 1 is an answer. Here's your homework for today. Please show all of your work, show all of your steps, and make sure to show that you are checking your work. Some of them, all of the answers will work. Some of them, only some of them, and maybe even some of them, none of the answers will work because you have something equal to a negative. But just take your time and show your work, please. Let me know if you have questions.